Hi everybody, welcome back. This is going to be our week 3 lesson. We're going to move on to section 3.2, which is all about one-step inequalities. Now, you might remember in the past in chapter 2, we learned how to solve one-step equations. So if you can guess what this section is going to be about, it's going to be about solving one-step inequalities. So if you're pretty good at solving one-step equations, you're in pretty good shape for this section. It's really not much different. The only thing we'll have to worry about is the inequality symbol. But the idea is the same. We're going to isolate a variable using inverse operations. Just a few reminders. When we are done solving an inequality, we also want to graph that inequality, and that's what we learned how to do last time. And we graph it on a number line, and we use a couple different things. One thing that we use when we graph an inequality is a type of circle. It's open if the symbol does not have a bar. It's closed if it does. The next thing that we do is we shade like an arrow shading in a particular direction, either to the right or the left. And the easiest way to remember it, in my opinion, is look at the symbol as if it's a mouth. If it's eating the variable, shade your arrow to the right. If it's eating the number, shade your arrow to the left. So I attempted to put this little reminder in the top corner of every slide where we're going to have to do graphing. So we'll do a little bit of review first. I provided you a number line here, and you'll have to do a little bit of graphing in your learning slides as well. So use this as a guide. And this inequality says x is greater than or equal to, that's what the bar means, -9. So the first thing I want to do is I want to find -9 on my number line. Here it is. And I want to put a particular circle either on or above it. I like to do mine above because it's just easier to see. So I either use an open circle or a closed circle. If you forgot which type to use, look at the symbol and then look at this table up here. My symbol has a bar. That tells me that I need to use this closed circle. So I'm going to drag and drop above the -9. Now I need to choose either an arrow that's pointing to the right or an arrow that's pointing to the left. And I may have to actually, if it ends up being this one, I may have to actually shorten it a little bit so that way it fits. The way that I did that is I just took this little circle here after clicking on the arrow, and I clicked it and I just shrunk the arrow's size. But let's see which one we'll actually need here. Because maybe I don't want that one. So to figure out which direction to shade, look at the symbol as if it's a mouth. See how it's like an open mouth? It's eating the variable. Well, when it eats the variable, oh, look at that. I don't even want this one. I want the one that's shaded to the right because that's what it tells me to do. If the symbol's eating the variable, shade to the right. We want all the values of x so that they're greater than. All of these numbers that are encompassed in this shading, which keeps going for forever to the right, are all going to be bigger than -9. Let's do another one. What is the graph of 0 is less than x? That's how I read this. First and foremost, let's find the 0. Here it is. And I need to choose the appropriate type of circle. My symbol does not have a bar. Based off of this little table here, I use the open circle. Now I need to figure out which way to shade, to the left or the right. Well, if I look at this symbol like it's a little mouth, it's eating the variable again. So again, I go to the right. If it was eating the number, I'd have to go left. Here's my final answer for my graph. Okay, now for the real meat and potatoes of this lesson. Let me move this table a little bit so we can see what's going on here. So right off the bat, this problem looks different from what we just did. Not only am I going to have to graph, I'm going to have to get the variable alone. You have to get the variable alone before you graph an inequality, meaning we have to solve this first. I've also put a line down my inequality symbol, the same way that you might have seen me do when we solve equations, where I draw a line down the equal sign just as a separation. So this is the left side of my inequality, this is the right side. The important thing is here, every time you write out your next step, you're bringing that inequality symbol down in your next step. Please don't change it to an equal sign. I've had a lot of students do that in the past. So if it was an equation, if this was an equal sign, and this said x minus 5, well, if I want to get the x alone, I want to get rid of this minus 5. How do I get rid of a minus 5? So I'm going to tab over. Well, I would add 5 to both sides. That means I'm going to have to add 5 to the right and to the left. So I'm going to do plus 5, plus 5, and then these right here are going to cancel. So in my next step, to get my answer, I just add these two. 2 plus 5 gives me 7, and I bring down not the equal sign because it's not an equal sign, but the inequality symbol. If you're having trouble finding where this is on your keyboard, it's right near the letters K, L, and M. I had to hit the shift button first before I pressed it. And then the x is by itself. Okay, now that I've got my variable alone, I can do like I did in problems 2 and 1 and graph this. Okay, but the important thing is you have to get to this step here first before you can graph it. I can't graph the original question. Okay, you can't graph the inequality and put the circle above the 2. You cannot graph the inequality and put the circle above the negative 5. This variable has got to be alone before you graph it. So I'm going to put a circle above the number 7. There's no bar under my symbol, so I'm going to use an open circle. Here it is. If I look at the symbol like it's a mouth, it's eating the variable. So again, I'm going to go to the right, and it looks like you're not going to really be able to see the arrow, so I'm going to shrink it down to size a little bit. And you could do the same thing in your notes. On your learning slides, you can shrink it. Oops. You won't have to worry about the number lines moving on yours. That's just on mine. You won't be able to interact with that part. But there's my final graph. There's my final answer. Let's do another one. And this is all we're going to do today. Solve one-step inequalities and graph. Solve, graph, solve, graph. Okay, so looking at this one, it says x plus 3 is less than or equal to negative 4. Again, I've provided a line down the middle just as a separation between the left side and the right side. Where I see an operation with the variable, that's where I'm going to have to do an inverse operation to isolate it. To get rid of this plus 3 near my x, I do the opposite of plus 3. I do minus. Whoops. I do minus 3. And I do it to both sides. Minus 3. These are opposites. They're going to cancel. So I'm left with x. And then I bring down my inequality symbol, which is a less than or equal to sign. To put that bar underneath, all you do, well, I'll actually keep going first. I want to get my answer over here before I do this. Basically, what you're going to do is you're going to just put an underline underneath it. So on the right, I have a negative 4 and a negative 3. I encourage you to double check your mental math using a calculator, either in the browser that you're in, you can just go to Google, or you can use that one that I left in Google Classroom on Desmos. If you have a cell phone and you've got a calculator app, you can use that. But whatever you use, if you're using a calculator, you should get negative 7, okay? Signs are the same, so I combine them, and I match the sign of the things I added together. Remember, you only get a positive from two negatives when you multiply or divide, okay? So, last thing that I need to do, it's an easy thing to forget about. This has a bar underneath, which means I want a bar underneath. I'm just gonna highlight my symbol, and up here, see where it says underline? Click it. There you go. There's the bar underneath. Voila. So now that x is alone, I can graph this. I'm going to find negative 7 on my number line and put a circle above it. The symbol has a bar underneath, so I want a closed circle this time. Now I look and see as if the symbol has a Pac-Man mouth or an alligator mouth. It's eating the number. If it eats the number, I shade left. not right. And again, I'm gonna have to shrink my arrow a little bit so it fits. There we go. So we shade to the left this time. Done. All right, here's another one. 21 is less than 7x. So I want to get rid of the 7. So what operation does it mean when a number touches a variable? It means multiplication. So the inverse operation that I want is division. So I think the easiest way to demonstrate that I'm going to have to divide by 7 on both sides, I'm just going to use the slash. Divide by 7, divide by 7. Do it to both sides. These cancel. And then on the left, my quotient, when I divide, again, double check your mental math and your calculator, you should get 3. I'm going to bring down my inequality symbol, being oh so careful not to change it to an equal sign. And on the right, all you have left is an x. My variable is alone. I can graph this. I need to find 3 on my number line. Here it is. No bar underneath means I want an open circle. If I look at the symbol like a mouth, it's eating the variable. I shade to the right. Okay, number 6. What is the graph of x divided by 2 greater than or equal to 3? Well, this is division. I want the opposite of that. So I want multiplication. I think the easiest way to show that I'm multiplying is to just put it in parentheses. Times 2 times 2. Opposite of division is to multiply. I know it looks a little weird on these Google Slides, but we just kind of have to do the best we can to make it look as accurate as possible. All right, so on the left, we just have an x. I'm going to type my symbol, being oh so careful not to make it an equal sign. And then on the right, I multiply. 3 times 2 gives me 6. I also need to go back to this symbol, highlight it, and make sure that I select underline, so that way it maintains that bar underneath. You don't want to change that about your symbol. So before you go to do your graph, always go back, double check your math, double check your symbol. Okay, so I'm going to find the number 6 on my number line. Bar underneath means I want a closed circle. If I look at it like a mouth, it's going to eat the variable, which means I shade to the right. A lot of them are shaded to the right, huh? Coincidence. I'm going to shrink my arrow too so we could see it. Uh-oh. I want the arrow. Oh no. Undo. Undo. Let's shrink it down here. I'm moving my number line. I don't want that. There we go. That's better. All right. What is the graph of negative 3x is greater than 21? Okay, so again, there's a minus sign, but this number's touching the variable. This means multiplication. The inverse of multiplying is to divide. So I gotta divide both sides by negative 3. Divide by negative 3. All right, pump the brakes here. You see how we divided by a negative? In math, when we're solving inequalities, there is a special rule where if you multiply or divide both sides of your inequality by a negative, you have to actually flip the direction of this symbol, okay? So I'm not going to make it open facing the variable now. I'm going to change its direction. Now you might be wondering, why do we do this? Okay, I can actually show you in a slide. I can insert a slide really quickly and show you why that is, but let's keep going with this one first. So if I divide here, I'm going to get negative 7, and now I'm going to graph it. Negative 7 is where I want my circle. No bar underneath, so open circle. The symbol, like a mouth, is eating the number, so I shade to the left. I'm going to make this arrow a little bit smaller. And I'm going to actually put a little reminder for us that in this one, if you multiply or divide both sides by It keeps wanting to capitalize that, and I don't want that. Here, let me fix this. I'm too particular with things, as you guys can see. Too particular. Too OCD. If you multiply or divide both sides by a negative number, you need to flip the direction of the inequality symbol. Okay? So that's what we did here. We flipped the direction of the inequality symbol. Okay? So why is this? Let me just insert a slide here and delete all of this. I'm going to make an impromptu change here. Why do we need to flip the direction of the symbol? Let's say we had an inequality that looked like this. 5 is greater than 2. That's what this inequality reads, right? And that's a true statement. 5 is greater than 2. Now, what if I took this inequality and I multiplied both sides by a negative number? And it can be any negative number. I'm just going to do -1 because that's the easiest. Well, what would I get on the left-hand side? 5 times -1 is -5. I'm going to leave the symbol the same, which is not what you're supposed to do, but let's see what happens if I don't follow that rule and I don't flip the symbol. On the right, 2 times -1 gives me -2. Now read this inequality. What does it say? -5 is greater than -2. Now, when they were positives, this was true. But you got to remember, negatives work backwards. -5 is not greater than -2. It is smaller. Okay, I always like to use the temperature as an example. If you think of temperature, which one's a lower temperature outside? -5, so 5 below 0 or 2 below 0? Well, this is much colder. This is much lower, so it's a smaller number than -2. So because I did not follow that rule and I didn't flip this symbol, this inequality is no longer true, okay? So if I don't flip, this is no longer true. Why is it here? Can I want this all on one line? No longer true. Here, let's just shrink it. Let's make it, there we go. So if I don't flip this symbol here, it's no longer true. So in order to maintain that this is true, I'm just going to copy paste in the next line, save myself the trouble. In order to maintain that this is true, I need to flip its direction, okay? So I need to flip it in order to maintain that it's true. So really the only trick that we're going to have to worry about that's different for inequalities versus equations is, well, 1, we're going to have to graph our final answer. And 2, if we multiply or divide both sides by a negative, we got to flip the symbol, okay? So let's try another one. Number 8, what is the graph of x divided by -1 is less than or equal to 11? So I need to get rid of this -1. Its division, the inverse, is going to be to multiply. And I have to multiply both sides by -1. These -1s are going to cancel, which means that in my next line, I'm left with an x. And notice what I did. I multiplied both sides by a negative. So I don't just copy this symbol down, I flip it, okay? And I'm also going to have to make sure that this symbol has an underline to make sure, that it still has a bar underneath. And on the right, I'm going to multiply. 11 times -1 is -11. Now I graph. Above the -11, I want a closed circle because there's a bar underneath my symbol. Mouth is now eating the variable, which means I shade to the right. Done. Okay, so those are all of the practice slides that I'm going to cover with you for the notes. So for your homework, and we're going to have 2 homeworks this week, the one that will be due Wednesday are your online learning slides. So basically, I'm going to give you a Google slideshow similar to this, and you're going to drag and drop after you've solved. So you're going to solve them first, just like I did, and you're going to drag and drop to create your graph. Please, please, please remember that if you multiply or divide both sides by a negative number, you have to flip the direction of your inequality symbol. Okay, let me make that red so it really stands out. I had to flip this symbol here and here. So I'm going to put this as a rule here as well. So if you multiply or divide both sides by a negative, you got to flip the symbol. And then on Friday, I'll have an interactive worksheet similar to the slides. You will type in your solution for solving, and you'll drag and drop the appropriate pieces for the graph. Okay, so give those a go. As is normal, if you run into any issues, just reach out and let me know. Take care.